In this video, I'm going to explain how entity models create a graphical user interface to allow users to input the parameter values for the class. I'm assuming that you have been following the tutorials in the recommended order, the order that we specify on our website. So I'm just going to jump right in. I have the Visual Studio project open. It's the one with F-Interface and F-Tutorial source code downloaded, and the project's installed as a part of the project. And I have Forge open, and I started Forge, logged in as my individual username, but I have not loaded a scenario. We don't need to load a scenario for this particular tutorial. You can see that I'm using the trial version of the engine and that I have the tutorial DLL that I created in my Visual Studio solution, and it's loaded. So it's the only DLL that's loaded. So before I get started, or as I get started, let me go ahead and pull up the window for the EXM sensor model. And that's the model that we've been using in a lot of these entity model development tutorials. So here's the graphical user interface for this particular sensor model. It has several parameters on here: a text field, a numeric field. It has a drop-down field that allows the end user to specify the measure for the max range. It has a drop-down field that just has two selections and a checkbox. It also has a question mark button right here that if I click this, it will actually open the documentation for this particular sensor model out of the tutorial documentation. So we're going to talk about how it is that this particular user interface gets displayed in Forge. Each class is allowed to, and has to, provide its own graphical user interface for its parameters. And of course, it makes sense that each class would need its own user interface because each class is going to have its own input parameters. And Forge has this magical ability to display the user interface for any class that's loaded out of a DLL in its windows. So when the class gets integrated and registered with Flames, part of that registration includes giving Flames enough information to be able to generate this user interface. You can see if I click the radar model, it's got a totally different user interface. So again, we're going to take a look at how this user interface gets created. So I'm going to go over now to the source code for this EXM sensor model. And it's right here in the sensor folder. And the first thing I want to do is just take a look at the class definition and how these input parameters are defined. So they're this normal C++ member variables of the EXM sensor class. So now we're going to talk a little bit more about the way that a class specifies its user interface. And that gets done with a special file that is unique to Flames. It's called the graphical user interface template file. So it has this extension of .tpp. So we usually name it with the class abbreviation followed by TP, and then the extension is TPP. If this was a class was written in C, the extension would be just TP. So I'm going to open up that graphical user interface file. And you take a look at it, you can see it's just a simple text file. At the top, we specify that this is going to be a template file that's for a class that's written in C++. If you leave this out, it will assume that the class is written in C, and it will generate code that's different. What happens is that we have a compiler that we simply call the template compiler that compiles this file, and it creates this file right here called tp.cpp. And since that code is automatically generated, you should never edit that code, and it's kind of difficult to read. Because it's an automatically generated file. Then if your class defines an include file, which it usually does, and that include file, if there's an include file for C, an include file for CPP, a C++ include file, those have to be included in this template file as well with a little bit different macro. The reason that we're including this fequipment.h is because just like in the source code files, there are data types in this particular file that are needed by the definitions that are included in the class file. So just like at the top of each of the files in here, we're including these two files. We do the same thing for the template file, which is a slightly different syntax. And the code generator, the template compiler, needs to know how to interpret the files, whether they're in C or C++. So let me go down here to the main meat of this file, and this is what we refer to as a Bob list. And sometimes we'll call it a layout type Bob list, or sometimes just layout for short. So the reason we call it a Bob list is that the fields on this screen right here, the different graphical user interface objects that we have, the name that we affectionately use here and kind of comically use here at Turnitin 4, the definition of these things is a Bob. So a field is a Bob, and a switch is a Bob, and a button is a Bob. So that's our general way of referring to graphical user interface objects. And we use that word because it's distinctive from other graphical user interface objects in other graphical user interface systems. So when we say a Bob, we're talking about a Flames graphical user interface. And more specifically, we're referring to a Joule graphical user interface object. Joule is the is the subsystem within Flames that we use to generate this entire graphical user interface. And it's also the subsystem that includes the template compiler that generates the code from this template compiler. And by the way, Joule is currently implemented on top of Qt. We've had lots of incarnations of Joule over the years that we've been in business. Joule has been written probably at least 10 different ways as the operating systems and graphical user interface systems have changed. But several years ago, we rewrote Joule to be based on Qt, and we've been very happy with that. So that's underneath that is all that we're using. But there are no Qt calls in any of the custom components that you write. Joule is a complete wrapper around that. So you don't have to know anything about Qt in order to be able to create a user interface for your classes in Flames. So in this template file, we've got a field definition here for each of the, or some type of Bob definition for each of the objects on our window. So I'm going to move this window over so I can see it at the same time. And so here's the one for the data processor. You can see there's the label, and then there's the max range and the max range unit measure field, which is a drop-down field, and then a drop-down integer field and a checkbox field for this field right here. And then there's a switch. Well, I mean, here's the switch. This is for the record results. It's a checkbox, and then the drop-down right here that says mode. That's this thing right here. So I'm just going to go over this very quickly. The full syntax for the template file language is in the Flames documentation. So I'm just going to go over it very quickly and there's lots of different examples or lots of different types of things you could do in a user interface. In fact, everything about Flames, the entire user interface of Forge and all the graphical applications is completely defined in these template files. So it's a pretty powerful mechanism for defining user interfaces. You'll notice here that we're not defining a window because the window is defined by Forge. It's the sensor's window or the window of another particular class. All you have to do is define the Bobs that you want for your particular class, and Forge will automatically display them in the right window in the right place. So we've got a field, as we talked about, and a couple of fields here. And now what I want to tell you is that we put these fields inside of a bob list. So the fields are not just free floating, they have to be grouped inside of a bob list. So the lowest level bob list that we're using here is a grid. And grid is real powerful. It automatically lines things up in rows and columns. And so you specify the row and the column with this cell statement. So this is the row and this is the column. So we've got row 2, row 3. So this guy right here, this unit of measure field, it's in column 2. And then this is in row 3 and row 4. So if you can just real easily specify where you want these things to be located, and it will automatically place them on the window. And as you've probably noticed, as you resize the window, it automatically moves things around and keeps everything all nice and lined up. This grid is placed within a horizontal box. So the horizontal box just arranges all the things inside the horizontal box horizontally, just left to right. So we have two things in this horizontal box. We have a grid, and then we have a button down here. And this button is the button for this little help button right here. So they are arranged horizontally, just left to right in the order that they show up in the box. And we have these little stretch commands right here, and that inserts spaces in different parts of the horizontal box. So we've got stretch on the left-hand side, and then we've got stretch in between the cell layout, the cell bob list, and this button. So that pushes the button all the way to the right, and it keeps this part of the bobs centered in the window. So if I drag this out of the window here and I'll move this around, you can see that even as I make the window bigger, it keeps those things centered in the window, and it's because of that stretch. Now the reason that they are showing up in the all at the top is because this horizontal box is actually placed inside of a vertical box. And the only purpose, there's only one thing in this vertical box, and that's this horizontal box. But the reason that we've got that horizontal box inside of a vertical box is because down here at the bottom, we've got a stretch. So that puts the stretch down here, and that's what pushes all these bobs up to the top of the field, top of the window, which is where we want them. So let's take a little bit closer look now at the definition of the fields themselves. I already mentioned the cell statement, and that has to be included in every object that's inside of a grid. And you can place other bob lists inside of a grid. So you could place a horizontal box, which we sometimes do inside of a cell within a grid. You can nest it in any depth you want. You can get really complicated user interfaces. Usually are all fields, so this is one of the most common types of bobs that we have, they will specify a type as well as whether or not they're editable. So this is an editable text. This is an editable float. So it tells Joule, tells Flames that there's going to be a float value entered here. So if I go over here and I try to type in a character, it won't let me type in a character because it knows it's supposed to be a floating point value in there. I have a label right here, and I'll talk about this IO record in just a minute. So there's the label, and with a field that is inside of a cell of a grid, the label is automatically placed in the column immediately preceding the cell where the field is located. So column 0 is a valid column. The columns and rows actually start at 0. So in column 0, this data processor label is automatically located, and this max range label is automatically located. So that makes it really easy to put a label on a field. I'll come back to the UOM guy in just a minute. So this is a drop-down integer. So he doesn't accept any keyboard entry. It's just mouse, and he's got two values here. Value, and we call them value pairs because the value of that's going to be displayed in the window is the first value in the pair, and the value that will be returned to the application is the second value. They're both expressed as text, but that's an integer because it says it's a drop-down integer. And the checkbox it doesn't have any, you can specify an initial value for that, but it returns a 1 or a 0. So it can only be an integer. I mean, I'm sorry, I said, well, it's a type checkbox. The overall field is switched. So there's radio buttons and other kinds of switches that you can have. So that's the main information that's provided in each field. So I'm going to go back and look at some of the other things. There's an option here, so if you want to put a box around it or not, and again, you can look in the menu for that. So what I want to talk about now is this I/O record, and this is one of the things that makes Joule really powerful and really convenient. An I/O record is just an arbitrarily named object in a template file. Our convention is that we name the record the same as the class abbreviation. We also name the top level Bob list the same as the class abbreviation. This is a requirement that you do that. So whatever your class abbreviation is, you need to make sure you name your top level Bob list. Inside here, you'll notice that most things don't have names on them. The only time we put a name on them if we have some reason to access an individual Bob directly, which we do in one case, but most things don't have names. In the Flames software that does I/O with this window, that gets the values off the window and puts them back on, there's no reason to access these fields automatically. It's because of these I/O records. So we have an I/O record here, and you can name this anything you want. Well, actually, no. If you want to use the default user interface stuff, this has to be named exactly the same as the class abbreviation. So we have just one I/O record here, and so since we're referencing that same name throughout the template file, Joule automatically associates all of these particular statements with the same I/O record. So because we're using the same name. With each reference to a record, definition of a record, we actually specify the name of our class data structure, which is right here, this class data structure. And then we actually reference one of the fields in our data structure. So we go back here and we'll look that every one of these I/O record statements is referencing one of the fields in our data structure. So Joule is automatically associating the value that is entered in this field with this particular field in our class. And that just saves lots and lots of typing, lots of coding. It eliminates lots of errors. It makes I/O with the screen virtually automatic. In fact, for most classes, you don't have to write any code at all. Absolutely no code to be able to do the I/O with this window because of these I/O records. So before I talk about this unit of measure field, I'm going to go and talk about where this I/O code can be referenced in the code. And for that, I'm going to go to the user interface file. And in the class definition, there are some methods that are inherited from the classes that are inherited by this EXM sensor. So CPP sensor has a bunch of abstract methods that they're virtual member functions, so they can be, you can choose to implement them or not. We have implemented quite a few of them here just as a way of doing a tutorial. And the user interface ones, where they're arranged alphabetically, but they are retrieve, and that's the method that gets the data off of the screen, and display is the method that puts the data on the screen. So I'm going to go look at the definition of those, and they're in the UI file. So we have class initialization here, which we've already talked about. Here's the display method, and here's the retrieve method. And you can see that there's just one line of code in each of these two member functions. The one line of code is for display is a JIO record set value. It has just two arguments. That's the name of the IO record, which we've already seen in the template file, and that's the instance of our object. So this one call takes all the values out of our object and automatically places them on the window. Similarly, when we do a retrieve, this one call takes all the values off the window and automatically puts them in our object. So there's another tutorial where we're actually going to modify this user interface and put another field on there just to show you how to do that. But you'll see in that tutorial that we don't change this code at all. And we don't have to. All we change is the template file and the definition of our class to add a few more fields in, and Flames will automatically do the I/O for our new class definition. Now, it turns out it gets even better. If your user interface functions, your member functions, can in fact be written to have just one line of code like this, then you can use the default user interface functions. So you don't even have to implement these functions at all. You can just delete them out of your definition of your class. So now I left them in here because I want to just show you this for tutorial purposes, but most classes don't implement this. So let me go to look at the FEX radar class and look at its user interface file. See, it doesn't have those methods in there. That's because it's able to use the default method. So there's no user interface code for I/O to the screen at all in most classes. Now, some classes have kind of sophisticated user interfaces. They've got more dynamic ways they can change things around, and for those classes they need to have some code in there, so they're not able to do all that they need with the default use method. So they will implement the method and they'll put some additional functionality in their code. But most classes can can do all of their I/O without having to have a user interface. So if you look down through all the tutorial classes, you'll find that very few of them have display and retrieve methods. So we're going to go back to the user interface file and talk about just one more thing. The user interface supports this automatic way of doing conversion, which I've already demonstrated. You can click on this and it'll automatically convert back and forth between different units of measure. That's done with this drop-down field. So this is just a normal drop-down field in terms of the way it's defined. It's always has to be a text field. That's a requirement if it's going to be used as a unit of measure field, a UOM field. And it has to have values. That the first value is the value displayed on the user interface, and the second value is a conversion factor. The conversion factor for the base unit of measure, and you choose that, what you want the default base unit of measure to be for your value right there. That is always 1.0. And these other values are the multiplier that you would place on values in meters in order to convert to miles. So this is the value to convert meters to kilometers. This is the value to convert feet to meters to feet. So these are not hard-coded in Flames. You can pick any conversion factor you want, any labels that you want. This is very flexible and very general purpose. I would recommend that if you're ever doing a distance type thing that you go and copy these and you use the ones we use these very consistently all the way through Flames, which you don't have to. We also have a convention that these are always no more than 11 characters. They can be less, but we never put more than 11. And that's because the value of this unit of measure also has to be retrieved from the window, so that when we save this in the database and then we pull it back in the database and display it, the unit of measure that was selected by the user comes right back. So we remember the selected unit of measure. So that's saved in this unit of measure character string. If we go back to our class, that's this guy right here. And our convention is that we always make these things 12 characters long. So with the trailing null, the actual string can only be 11. So you'll never find in our template files a unit of measure conversion factor that's more than 11 characters long, 11 total characters long. Now, again, this is just a normal drop-down field, a normal text drop-down field. There's nothing special about the way we define this field, except but there is a requirement that it's a text field and that we define the value pairs as I've described. What makes it get this special behavior is this statement right here. If I have a floating point, or it has to be a numeric field, it can be integer or floating point or double. If I specify that there's a unit of measure field, all I have to do is specify the name of the name of the field, which I have done right here. And that statement is enough to let Flames know that this particular field is going to be used for conversion, and it's all done automatically. And I can place that field anywhere that I want. I usually place it in the grid to the right of this. So it's in the same row and it's in the next column over, but you don't have to. You can place it anywhere you want. There's no requirement on placement. But again, that special statement right there automatically does the unit of measure conversion. And no matter what unit of measure the user picks for this, no matter what it is, the value that comes back to your code and gets stored in your object will always be in the base unit of measure. So your code never has to worry about doing any conversion, never has to check what values the user has specified in the user interface. It's all done automatically by Joule, and the value that you get back in your object when the values are retrieved off the screen, the value that gets saved right there, will always be in your base unit of measure, whatever you choose that to be, whichever one you choose to be 1.0. So even though we specified kilometers, if we went in the code and looked at what got pulled off the screen after the retrieve method, it would be 10,000 meters rather than 10 kilometers. So this is how Flames user interfaces are defined. Every one of the Flames classes has a template file like this. If you want to learn how to do more complicated user interfaces, you can just look around in Flames at the different user interfaces that show up for different classes. If you see something that is on the screen that you would like to use in the user interface for your class, just go find its template file, copy and paste the values over, and you can make use of that in the user interface of your class. So it's very easy to copy stuff from one class to another. Now there's a tool that is used in Flames to help us define this, or at least make it easier for us to define it. If I want to make a change to this, I can make a change, I can compile it, and then I can rebuild the application, start Forge back up, and look at my change. That tends to be a little bit tedious because every time you make a change, you have to actually rebuild the application and restart it and then come to this window and take a look at it. If you have just a real simple change and you've done it before, I oftentimes, if I'm going in and I'm just making a small change, or sometimes even kind of big changes, I'm pretty comfortable working with template files, and so I'll make the change and I'll just build it and take a look at it, and it'll be just one or two changes, and I'll get it the way that I want it. But if it's more complicated, or I'm new to template files and I'm not really sure what different options and things are going to do for me, then I will use this other tool called the window viewer. We're not going to talk about that in this particular tutorial. When we go to the tutorial where we're actually changing this user interface, we will use the window viewer. And you'll see just how nice that is and how flexible it is and how convenient it is. We purposely did not create a WYSIWYG graphical way of defining user interfaces. We think that's way more cumbersome than just being able to edit things in text and display it very quickly in the window viewer. So you'll see how we do that in the tutorial for changing this user interface. So that concludes this tutorial. Thanks for listening.